Good morning. I'm Libby Dayton. I'm a soil scientist in the School of Environment and Natural Resources. Today I want to talk about a project that we're just kind of finishing up, but now we're starting the next phase, which will be implementation. So we've been working on a project called On-Field Ohio, which is a revision of the Ohio Phosphorus Risk Index, which I think Andrew alluded to in his talk earlier. So what we're attempting to do is provide a long-term average field scale estimate of erosion and phosphorus runoff risk based on field properties and farmer practices. Increasingly across the United States, these P indices are increasingly being used to judge farmer performance, so it was really important to us to get it right. So a little bit about the project. We had edge of field monitoring set up on 29 fields around Ohio. We had 8 fields in Grand Lake St. Mary's, 7 in the Scioto watershed, and we had 14 fields in the western Lake Erie Basin. Most had both tile and surface runoff monitored. Some had just one or the other. And I always like to say a special thank you to our participating farmers. So for every runoff event over 1 to 3 years, depending upon how long the samplers were out there, for both surface and tile runoff, we collected the dissolved P component, the particulate P, which we've heard a lot about today, component, which added together is the total P. We measured the suspended sediment and the runoff flow volumes. For every year on all of our fields, we looked at the erosion potential for each crop year in a rotation and averaged across the rotation. Every year we went out and soil sampled, and the farmers were kind enough to share with us all their farmer management practices. So taking all that data, we then went back to the office, and we've spent the last year really correlating our edge of field runoff results with the on-field properties and practices that we observed. So we've used a combination of some empirical relationships between our edge of field data and what we see coming off. And we've also done quite a bit of work tailoring the Apple model, which is the annual phosphorus loss estimator for Ohio conditions. So we've calibrated that using our edge of field data and also integrating the erosion program, Russell 2, into the Apple. So coming soon, and I think that we're hoping that we're going to be opening this up to the public by the end of the summer. We're looking forward to that. We're in the final sprint here. And so we'll be putting an online tool, an online calculator online, so that a farmer can sit down and they can run their current practices and they can compare with maybe if they want to change their practice and see how that would change their results. So using our developed equations, the farmer can find out their erosion potential, their surface and tile, pound per acre risk of loss for dissolved, particulate bound, and total P. They can also look at their fertilizer manure application plans and find out what the risk of additional P loss is that's associated specifically with those practices. So this is essentially what will be delivered to the farmer in terms of output. So again, they get their erosion, they get their soil tillage intensity rating based on their practices, and then they get surface and tile, a particulate and total P, as well as the fertilizer P. So we feel the power for this is really going to be in comparisons. So I brought just a couple of examples to show you where we're heading with this. So if we look at a single field out, and this actually, we randomly pulled this from Mercer County. It's a single field with a 2 to 4% slope, a blount silt loam, and we look at 2 different crop management scenarios across 3 different soil test P levels. So we look at a typical rotational tillage in Ohio where there's a chisel before, in the fall before corn. We also compare that to all no-till corn and beans. We look at 3 soil test levels, 15, 50, and 150. So these are the results. This is what the tool would tell the farmer. So the first thing you can see is a huge difference in the erosion potentials between crop management scenario A and B. And you see that translates strongly into how much particulate P, surface particulate runoff, there is. And you can see that even though surface particulate runoff increases as soil test P increases, there's always a huge decrease based on mitigating your erosion. And then for all the dissolved components, those are really strongly tied with those soil test P levels. So you see, as the soil test P increases, those just increase. In fact, as we move from our rotational tillage and move down toward more of a no-till situation, we get about approximately an 80% reduction in erosion on this field, and that results across all the soil test levels in a 71% reduction in surface particulate P runoff. As we increase the soil test P from 15 to 150 on this field, then we could expect from our tile runoff to see a 2-time increase in particulate P, a 7-time increase in dissolved P, and a 9-time increase in the surface dissolved runoff P. So now let's look at how that translates, well, this might take a minute to open, across Ohio. So now we run the same simulations but across Ohio, although I didn't manipulate the soil test levels here. So the soil test levels here actually more accurately represent the distribution of soil test levels in Ohio. So here again, comparing our two crop management scenarios, we can see huge differences. And these differences are going to become really important when we're asking for 40% reductions, or we're asking for any reductions. We have to be able to see, well, where are we starting and where are we heading? So this is an example of erosion across Ohio, again running the Russell program, and you can see big differences between a rotational tillage and no-till. And then if we also look at, this is surface plus tile runoff total P comparisons between the rotational tillage and the no-till. And to get this, we didn't change the soil test P levels. And so you can see again, there are really good opportunities here to see big reductions simply based on changes in practices. And of course, we're always encouraging farmers to maintain their soils in that agronomic soil test range. So for Ohio, it was a big move to move the Ohio P risk index from completely qualitative to much more quantitative. We hope that this tool will allow farmers to quantify how their voluntary practices, changes in practices, can contribute into achieving the water quality targets that they're being asked for. We are setting the results interpretations are set so that we can achieve the Great Lakes Water Quality Agreement 40% reduction goals. Oh, and that's me. Thank you.